Imagine this. You've left some salt on the table, and while you were gone, someone sprinkled sand into it.
Now it's all mixed together. But here's the important thing. It hasn't reacted. The salt and sand are still separate substances, just jumbled up.
The question is, how do we separate them? How can we get a clean pile of salt back and a separate pile of sand? That's exactly what we're going to explore today. Welcome to our lesson on separating mixtures. By the end, you'll know 4 clever methods scientists use to separate mixtures back into their original parts.
So let's pin down the definition of a mixture.
A mixture is a substance made of 2 or more different elements and/or compounds. But here's the key part. They are not chemically joined together.
Right. That means each part of the mixture keeps its own properties. Salt stays salty, sand stays gritty, even though they're mixed in the same pile.
And that's why mixtures can be separated, because the ingredients are still independent, just sharing the same space. Let's think back to our salt and sand, all mixed up on the table. Now that we know what a mixture is, it makes sense. The salt and sand are 2 different substances, 2 different compounds, but they're not chemically joined together.
That's why it's possible to separate them.
So, how do scientists actually separate mixtures?
There are 4 main techniques you need to know.
First up, filtration. Imagine you have sand mixed with water. If you pour it through filter paper, the water passes through the tiny holes, but the sand is trapped. This only works for insoluble solids and a liquid.
Next, crystallization. Think about salty water. If you heat it, the water evaporates away, leaving behind solid salt crystals.
This method is used for soluble solids and liquids. The third technique is known as distillation. Now imagine ethanol and water, 2 liquids that mix well. Ethanol has a lower boiling point, so it evaporates first. The vapor passes through a condenser, which cools it back into a liquid. Distillation works because different substances have different boiling points. And last but not least, chromatography.
Not all substances dissolve the same way, and even those that do can have different solubilities.
On chromatography paper, substances that are more soluble travel further, while less soluble ones stay closer to the starting point.
That means they end up separating out.
So, there you have it. Filtration, crystallization, distillation, and chromatography. 4 clever ways to separate mixtures.
Here are the key takeaways from this part of the course.
If you want to explore more, check out the related videos on screen now. And don't forget, like and subscribe so you never miss out on more science made simple.
Thanks for watching.